Section 1.5 is on continuity. And in terms of that, you think of, can you sketch a function without lifting your pencil off the page? If you can sketch that way, then your function is continuous. But if you need to get to a certain point, lift your pencil off and move it somewhere else, then you have a discontinuous function. You do not have continuous. So algebraically, there's three main things we look for a function to be continuous at some specific point A. Is it even defined at A, meaning does the point exist? The domain isn't zero. Does the limit exist at this point A? And if the limit exists at the point A, is it equal to the function at the point A? Now, when we talk about a continuous function, usually we talk about its continuity over an interval, and that's where the function is continuous, every value inside of that interval. Otherwise, to be discontinuous at some point, not an interval, but discontinuous at a point, is when a function is not continuous. So we will look at these three types of discontinuity. So a removable discontinuity is when you have a spot that's been removed from your function. Maybe it exists up here. Maybe there is no existing point at A, but we still refer to that as whole discontinuity, but HOLE, not WHLE. The other is jump discontinuity, and this is where not only is there a dot and an open circle, but the key here is the direction or shape of the function completely jumps to some other level. And the final type of discontinuity is infinite, where there is some value A, and basically the graph does not cross. It kind of hits that invisible barrier line, and we're going to be going to infinity vertically or negative infinity vertically at some individual point A. And the thing is to notice that each of these continuities, each of these three, break one of the definitions above. So kind of looking at it together, whole discontinuity, the limit exists, but the limit does not equal the function. This one is particularly defined, but if there was no dot, it wouldn't be defined there. Jump continuity, the limit doesn't even exist. So the point is defined, but there is no limit, so therefore the limit can't equal the function. And lastly, in terms of infinite discontinuity, the function is not even defined at point A. There is no x value.